a coolglow nightlight by Timeguard, which is a prominent sort of brand of plug-in gadgets like time switches in the UK. And these haven't been around for a while, so I saw them being sold on eBay and I thought I'd buy one. So let's take a look at it. The point of these things is that they have a very small fluorescent tube inside them, which is quite unusual. And the circuitry tends to be fairly straightforward. And in some applications, I've just seen a simple resistor used. I'm noticing that this one's had a terrible trip through the postage. Its earth pin has been snapped, so I'll have to be careful it doesn't come off in the socket. So is there anything worth reading this? Provides non-heat blue luminescent light. Looking forward to the blue luminescent light. Power consumption, it says 3 watts max. Okay, so let's bring in the hoppy. For those of you asking why I can't change the speed of the multiplex in the display, it's because it's built into the software in the hoppy. It looks fine to me, it looks rock solid to me, it just seems to clash with the camera a little bit. So if I plug this in now, and I turn it on, oh, that doesn't look very blue, that looks white to me, very shimmery as well. Oh God, it's a complete shimmer fest. It says the power is 0.95 watts, but the power factor is 0.09. That's less than a tenth. That's well, not less than a tenth of a power factor. That is basically just under 0.1 of a power factor, which is really bad because 1 is ideal. So that suggests that there's probably some sort of capacitive dropper, and I can see a yellow capacitor in here. So that's fundamentally it. It glows in a shimmery style. It's much shimmerier on the camera than it is in real life. It just looks like it's glowing, but there is a slight shimmer. I wonder what that would be like if it was left for a while, but we're not going to find out because I'm going to take it to bits. I'm pretty sure that RS Components used to sell, if they don't still sell, little tubes like this, and the way you ran them was with resistors in series as sort of ballasts and also for helping them strike. So let's get a screwdriver down here. There's 2 screws, one at diagonally opposing corners. And what will that reveal? Okay, so here's the circuit board. I wonder if the capacitors are, I've got discharge resistors. Well, they're discharged now. Right, so there's a tube which has 3 wires going into the end, each end. Let's say I get down this a little bit. There's what looks like it could be a capacitive dropper here. And some resistors, but no diode. I was possibly thinking it might have used a voltage multiplier. I wonder if it's using the auxiliary electrode system at the end to actually help strike these. Right, give me a moment. I'm going to reverse engineer this and we can take a look at the circuit. The reverse engineering is done. There's a couple of oddities here. See this yellow goo here? It's almost as if they've painted some other yellow stuff into the underside of that capacitor. That's odd. I don't think they're using it to glue it down. It just seems like maybe they've had a batch of capacitors that have been a bit exposed and they've just added some more yellow resin. That's very weird. Other odd things, there's a diode shown here, but they've got a resistor there, and that kind of does make sense. I don't know why there's a diode symbol, unless this was designed to have other functionality. Oh yeah, you know what? Oh wait, no it doesn't. No, I saw the R2 and thought that might be in a position for a resistor and they put a capacitor in, but C1 is actually the capacitor and the R2 is the discharge resistor. But anyway, I did what I usually do. I didn't use fancy glossy paper this time. I just did it on matte paper, the standard cream coloured paper I use for better contrast. And I just flipped this image over and drew the components on and then reverse engineered it. Now, this, initially, there's a track here that is actually off and it's obviously detached from the pad, maybe when they're poking a wire through soldering it. So they've bridged a piece of wire across here. And initially I thought that was shorting onto here, but it is actually, that's where the wire actually comes down. It links onto this track down here. So that's okay. But they've just kind of bodged a repair in here with a bit of wire. very strange. So I've drawn this out and I'll explain how it works because it's quite neat. The tube actually has 3 wires going to each end and the 2 outer ones are just common together. I've not shown them common together, just for simplicity of the circuit diagram. It's using a capacitive current limiter, and there's the yellow capacitor for a start. It's just across live and neutral. Then there's a 100 ohm resistor. Was that 100 ohm? Let me just double check that. Pretty sure that was 100 ohm. It is a 100 ohm, just to limit inrush current and stuff like that. A fairly generous 470 nanofarad capacitor, that's where that terrible power factor was coming from, with a really huge 1 meg ohm discharge resistor. They'll have chosen the really big discharge resistor because it's got a higher voltage rating, so they've done it by the book, so to speak. And then the tube itself has 2 igniter resistors, and here's the interesting bit. You see, initially, if I just draw one end of the tube here, with the loop electrode coming in and the auxiliary electrode. Initially, when you power that up, if it's not lit, if there's not enough voltage across this tube, well, it's not so much in the case of if the tube isn't conductive enough, the ionized gas and the mercury vapor inside it, then it won't light and there'll be a fairly high voltage across the ends. And because this middle electrode is very close to the other electrode, a resistor connects it to the other end, so there's a quite high voltage between these, and it causes local ionization between those, a little glow, which would help get the mercury vapor into sort of movement and also break down the voltage of this electrode here, resulting eventually in it lighting across. So these 2 electrodes, each have their own little starter electrode. It's very reminiscent of the mercury vapor lamps. Oh, let me doodle that out. That's quite useful to actually mention. I'll come back to that in a moment. If you've ever seen the old street lighting mercury vapor lamps that look like this, they've got this big dome and then usually a little pip at the end and comes down, and they're white and they glow this really greyish bluey white. Inside those, they're kind of more elliptical than that, but this is the way I've drawn it. Inside those is a mercury vapor quartz tube that is designed to pass UVC to light the phosphors, because the phosphors are actually on the inside of the outer globe. There's a slight vacuum in there as well to keep the inner tube hot. And those generally have an electrode coming in and then going down to the other end with a fairly strong support, and then they've got another electrode here. And then at one end, there'll be a little auxiliary electrode, just a little electrode that comes in through here and tilts over, and it'll be connected down to the other end with a resistor. The resistor is quite a special resistor, and it bonds across onto that. And initially when you start these up, the open circuit, if the lamp was cold, it wouldn't actually start glowing. But this resistor leaks current to the starter electrode, which then results in a slight glow in here. That causes local ionization. It gets that mercury vapor into the sort of movement, and initially you see them sort of glow and sputter at that end, and then then it ignites across, and then it warms up. And as it warms up, the electrodes will actually start heating, and they'll be. It's running kind of cold cathode. It gets there's a thermionic coating in this that will emit electrons once it's heated up. So once it gets into the swing, you'll get quite a strong discharge. The special thing about this resistor is that if you smash the globe on these, and it was not uncommon for people to throw stones at the street lights and smash them, and then it would smash the outer shell. And if the outer shell is smashed, then UVC light will come out, and that poses that risk of skin and eye damage. So what actually happens there is, if it's working, this resistor is made of a material that will react with oxygen, and if it does, then it will burn out. And when that happens, the lamp should theoretically not strike up when it's turned on. But I have digressed horribly, haven't I? That's gone a completely different subject. I do have the head of a mercury vapor light through in another room. I could just show you it, but there's not much inside because it's very clear that the ballast was. I don't think the ballast in the top. I think it must have been down in the bottom of the lamppost. So that's fundamentally it. The current is limited by this on each half wave by a portion being allowed through this capacitor. The tube will then glow if it's up to temperature, but if it's not, these 200k resistors will leak current from each side to the igniter electrode, the one that makes it easier for the glow to be initiated at the ends and start warming it up and getting that mercury vapor in movement. And this 68 nanofarad capacitor must just be for interference suppression, or maybe to take spikes away to actually stop them interfering with, because a sudden spike would actually just effectively pass through that capacitor. It passes AC, and it will see a spike has a changing current, changing voltage, so current will flow through. So I don't know if I think it must purely be to reduce noise though. I don't think it's to filter out spikes to stop current pulses in the tube itself. I think it's fairly robust that way. So it's a fairly interesting little thing. I wonder what other application they use these for. I definitely remember they made them in different colours, but they were designed for lighting instrumentation panels and stuff like that. I do see under the phosphor, the outer electrodes, I do see what looks like in the end of the tube. It looks, looking up the end, as though it might possibly have a tiny little filament going across there as well. But there's one way to find out. That's to cut one of those wires and measure it with a meter. Let's bring the meter in. So the wires are twisted together at the end here. Let's separate them. Could chop. And see if there's a resistance between the end of those. There may not be, it might just be a solid electrode, or it might be a dual-purpose tube that is designed to take the heated filament, although they might also have just used the heated filament as... So I would expect a fairly low resistance for that. Maybe not. I might not be getting a good connection because these are Dumé metal. They're oxidized on the surface. I should really scrape them with a blade. Dumé, if I'm pronouncing it, or Dumet, I'm guessing it is Dumé, is a alloy of, I think it's iron and copper. And its main characteristic is that it has a very similar thermal coefficient to glass, coefficient of expansion. I'm going to just grip this on my fingers here because they won't really affect the... That is about 8 ohms. So that is a significant resistance in there. I should actually bring this in. That would be a lot better. So you can see for yourself. So that does seem to be a wee filament inside there. Just double checking something. Yeah. So these electrodes do actually have a little filament. So maybe they could be used as heated cathode lamps, little hot cathode filament lamps as well. Or maybe they've just used the existing filament technology because they've already got these filament materials with the thermionic emissive coating on them. And it's just kind of a reuse of an existing product. Thoughts on that in the comments below. So it's an interesting little thing. It's quite unusual. It's a long time since I've seen one. Slightly disappointed that it's not got the promised blue light unless you consider cold bluish white light. Look at the seal in that. That's enormous, isn't it? But they're not really too bothered about that because there's plenty of space for it. Interesting. Very interesting. So there we have it. Inside a Timeguard. What do they call it? Cold nightlight, just because it is using a little sort of cold tube inside instead of the filament lamp.